I want to clarify a few things about the video that you watched on conditional probability, because you were given a conditional probability formula, and although that's an accurate way to calculate conditional probability, I think there's a much simpler way to kind of go about it. So basically, we use conditional probability when we have a larger sample space, a larger set of data, and within that larger set of data, we want to look at a specific part of it. So for example, if I was talking about our class, and I wanted to say from our class, what's the probability of picking out someone with brown eyes given that they're a girl? Well, then I don't really care about the whole number of our class. I just want to look at the girls and see what's the probability of picking out a brown-eyed girl out of the girls. So that's what's kind of happening with conditional probability. So number 2 from your notes says, if we're looking at the numbers 1 through 100, and you're going to randomly select a number, what's the probability that it's a perfect square given that it's an odd number? Well, we don't really care about all the numbers 1 through 100 because we're already given that it's an odd number. So really, we're only looking at the odd numbers between 1 and 100. So out of all of our data, there's really only 50 numbers we're choosing from because it's given that it's an odd number. So 50 odd numbers, and then of those 50 odd numbers, what's the probability of choosing a perfect square? So again, we're not counting all of the perfect squares between 1 and 100. We're really only counting the perfect squares between 1 and 100 that are odd. And so there are 5 of those: 1, 9, 25, 49, and 81. So 5 out of all the odd numbers, there are 5 perfect squares. So the probability of drawing a perfect square out of the odd numbers is 5 out of 50, or we would reduce that to 1/10. Let's look at another example from your notes, and I'm going to do it a slightly different way. So number 4 is another one where we need to use conditional probability, but I'm going to teach it slightly differently. So number 4 is talking about the 30 students in a class, and it kind of tells you how many of them are in band, how many of them are athletes, and then how many of them are in band and are athletes. So 13 are athletes, 9 are in band, and 3 are in both. And so a Venn diagram was drawn to kind of show you that breakdown, and I do think the Venn diagram is helpful. If you're a visual learner and that makes sense to you, use the Venn diagram. But I don't want to overthink the conditional probability formula here. So we want the probability of band students, of drawing a band student randomly from the class, assuming or given that they're a non-athlete. So even though there are 30 students in the class, if we're given that they're a non-athlete, we're really only looking at all the non-athletes from the class. So instead of our denominator being 30, our denominator is going to be however many non-athletes there are, and it says that there are 13 athletes of 30 students. So if of the 30 students, 13 of them are athletes, that means 17 of them are non-athletes. Sorry, we're really only looking at the non-athletes here. And of those non-athletes, how many of them are band students? What's the probability of drawing a band student out of those non-athletes? Well, it says that there are 9 students in band, but 3 of those band students are athletes. So the 3 band students that are athletes would not be included in this 17, kind of like the Venn diagram showed. So that means there are only 6 non-athletes that are in band. So there are 9 students in band, but 6 of them are not athletes. And again, we only care about the non-athletes because that's the given that we were given to work with. So our probability of drawing a band student out of all of the non-athletes in the class would be 6 out of 17. The last example I want to look at with you is number 6, where we have a two-way table drawn. And one of the first things I do when I have a two-way table, especially if we're going to be calculating some conditional probabilities, is I like to just go ahead and add up the totals of my rows and my columns. So we've got juniors that said yes to prom, juniors that did not go to prom, seniors that did, seniors that didn't. But I want to know the totals. So total amount of juniors is 28 plus 56. Total amount of seniors, 97 plus 19. Total amount of people that went to prom from juniors and seniors was 125. Total amount that did not is 75. And then if I wanted to know the total, like how many students are we talking about here, we could add up all of these boxes or add up our totals here or add up our totals there. And basically we get that there were 200 students that were surveyed for this particular problem. So that's all the information that we probably need to know to answer these questions. But again, I think it's helpful to go ahead and have those totals ready to go and to use. So the first question on number 6 says, what's the probability that a randomly selected student is a junior that did not attend prom? This one is not conditional probability because it doesn't say a junior that did not attend prom given that blah, blah, blah. It's just what's the probability of drawing a random student that was a junior that did not attend prom. So we look at the juniors that did not attend prom, and there were 56 of them. And we want to know our denominator then. So probability is 56 out of the total number of students there are in general. In this case, 200. So 56 out of 200. So out of all 200 students, the probability of drawing a student that was a junior that did not attend prom, did not attend prom was 56 out of the 200. Or we would reduce that, that reduces to 7 over 25. So our answer to A there would be 7 out of 25. All right, B. B says, what's the probability of randomly drawing a student that did not attend prom given that they're a senior? So this is conditional probability. So the given is that they're a senior. So we're only looking at the seniors here. So our total is not 200. Our total is how many seniors are there? And we already added those up. There are 116 seniors. So that's going to be our denominator. That's kind of the sample space that we're drawing from, given that it's a senior. So out of our seniors, 116, what's the probability of drawing one that did not attend prom? So seniors that did not attend prom were 19 out of the total number of seniors, 116. And that does not reduce, so that would be our final answer to B, 19 out of 116. Lastly, C. C says, what's the probability of randomly selecting a junior given that the student did attend prom? So again, we're only looking at the students that attended prom. We're not looking at our total amount of students surveyed here, just the ones that attended prom. So the number of students that attended prom total was 125. So that's our total. And we want to know what's the probability of those that attended prom of pulling out a junior. So juniors that attended prom were 28. So we would have 28 juniors attended prom out of the 125 students total that attended prom. And those would be your 3 then conditional probabilities for the, or I guess this first one wasn't conditional, but those would be your 3 answers for number 6.